Hello everybody, and welcome to Unit 8, Metamorphism and Metamorphic Rocks. So Section 1 covering metamorphism. What are we talking about here? So this is our larger rock cycle. We start with sedimentary rocks here, or igneous rocks here, and we put them through this process, metamorphism. This is rock cooking. And just like with regular cooking, you don't actually melt what you're dealing with, the food. You don't light it on fire, usually. Instead, you add enough heat to it to produce some sort of chemical changes in it, but without completely destroying it or reforming it. So what do we start with? We start with our protolith. This is our first rock. Proto first, lith is rock. This is our original uncooked rock, which then becomes a metamorphic rock. This is our parent rock, in a sense. And we put it through the cooking process. So meta and morph. Meta means change, and morph means form. So we have a change in the form of the rock. It's not a complete melting and reforming of it. It's more of a cooking process. And it can be any of these changes here, changing the mineral forms, changing the texture of the rock, changing the chemistry slightly, or changing the internal structure. And this all happens in rocks which are below the area of diagenesis, so deeper in the earth than wherever we're forming our sedimentary rocks. This is what happens below that. This is a result of high temperatures and high pressures. As something sinks deeper into the earth, it's not just going to get higher in terms of pressure, but higher in terms of temperature as well. By and large, these two are coupled. They kind of go together. It's impossible to go deeper in the earth without experiencing both of these usually. So what are our different grades? We have medium rare, low grade metamorphism, so pressure and temperature conditions up to 400 C and 400 MPa. This is M for mega, means million, and pascals, which is a unit of pressure, so 5 to 15 kilometers below the Earth's surface, or well done. So this is even more than 400 C and 400 megapascals, 15 to 35 kilometers below the Earth's surface. And just as a point of reference, 35 kilometers is about how deep the continental crust is. So everything all the way down to the bottom of that crust. And for reference over here, 400 C is about 750 degrees Fahrenheit. So an oven, most of them go up to about 500 at the max. The break-even point to be considered high grade for rocks is 750, so a bit above that. In terms of pressure, the pressures get to be very, very big. So tire, think of these as being pressurized. These are at 0.2 megapascals, have a human bite strength, and a bullet here is 21 megapascals. Again, compared to 400 to be considered high-grade metamorphism. Lots of pressure. And this diagram puts into a visual what we've been talking about here. So we have some region of the Earth, our continental crust, and as we go down, we're first in the region of diagenesis. We're making sedimentary rocks. It's enough to squeeze the water out and press the rocks together, but not necessarily to cook them. As we get a little deeper, we get low-grade metamorphism, and then high-grade metamorphism, and then finally, if we add too much heat, then we start to melt, and we have liquid rock. So over here, we have our region first of diagenesis, where sedimentary rocks are pressed together and made. Our regions here, medium rare, to rare, and well done, where we make metamorphic rocks, and then finally, melting. We get all the way down here, and we actually form igneous rocks through the amount of heat that we add. Next section is going to cover textures of sedimentary or metamorphic